Rookie students. So today we are starting chapter 13, and that is all about conjugated unsaturated systems. And trust me, I know that conjugation can be a little bit scary from a personal experience. Boo. But anyways, I know that you guys have got this, so without further ado, let's get started. Conjugation is a pretty simple concept to understand. First, we're going to look into our three main vocab words, which are conjugated, isolated, and cumulated. So I'm going to explain what each of these words mean and show you an example because it's a very straightforward concept, but it's easier if you can visualize what we're talking about. So conjugated just means that we have two or more double bonds that are one single bond apart. Such as this, we have double bond, single bond, double bond, and we can even go further and also put this into conjugation. So to summarize, like I said, we are going to write that conjugated means we have two or more double bonds that are one single bond apart. So now isolated is similar, except we have double bonds that are more than one carbon apart. So let's say something like this, where we have two double bonds in the system, but they are actually 1, 2, 3 single bonds apart. And we can kind of think about this because isolated, the term isolated means by yourself, far apart, away from others. So each of these double bonds is isolated from the other double bonds. Cumulated is actually the opposite. Cumulated just means that we have two double bonds directly on the same carbon. So I'm going to draw out this carbon so it's easier to see. And we have one double bond here, and we have another bond on this carbon, and we have another double bond directly attached to the same carbon. So cumulated just means that the double bonds are on the same carbon. And as the word says, cumulated, all of the double bonds are accumulated in one area. So in summary, we can say conjugated is when we have double bonds that are one bond length apart. Isolated is just any double bonds that are more than one bond length apart, and cumulated means that they are on the same carbon. If we think about this logically, we can kind of figure out what the order of stability would be. So I'm going to draw the order of stability in red. We can tell that cumulated is not very stable because of all of this steric effects and electronic effects and all the unhappiness that's going on right here. We're not happy, so this is actually going to be the least stable. Isolated is just kind of in the middle. It's nothing special. Just sometimes there's double bonds, sometimes they're far apart. It's whatever. Conjugated, though, is really special because having double bonds that are in this one bond apart setup means that we have a delocalization of charge across this whole area. So now these electrons are going to go all across this this molecule, and it becomes more and more stable. And also we can have some special effects because of the overlap of the orbitals, but that is a bit beyond the scope of this class, so we won't talk about that. All you need to know is that stability goes this way. Conjugated is the least stable, isolated is meh, and so all you need to know for this class is that stabilization goes in this direction, cumulated is super unstable, isolated is in the middle, and conjugated is really, really stable. Within conjugated molecules, we can also say that the higher level of conjugation the higher the stability. So we can say that the higher the level of conjugation, the higher the level of stability. And what I mean by that is the more double bonds that we have in conjugation, the more stable you will be. So if you have a molecule like this with 2 bonds in conjugation versus this with 4 bonds in conjugation, the 4 double bonds in conjugation has a higher level of conjugation, therefore it is more stable. Ta-da! So that is our intro to conjugation. Now that we have that information all squared away, we can actually move on to the handout and do some examples. So in the first example right here, between 1, 2, and 3, we have to figure out what's conjugated, what's isolated, and what is cumulated. So in my opinion, the easiest one to see straight away is cumulated, because we see that these 2 double bonds are right next to each other, attached to the same carbon. It makes the molecule look kind of weird. Now, when determining isolated and conjugated, we're going to go ahead and highlight the double bonds. And we can see that on the example on the left, we have double bond, single bond, double bond. So that would be conjugated. Versus here, we have double bond, single bond, double bond. So that would be isolated. And if we were to take this question one step further, we could rank these in the order of stability. So this would be the most stable, and this would be the least stable. And again, isolated is in the middle. If we have the same logic for the next question, we can see again, this would be the cumulated molecule. Next up, we can obviously see that these are very far apart from one another. And let's just double check. 1, 2, 3. Yes, they're 3 bond lengths apart. So this is isolated. And the last one, as we can see, 1, 2, 3 double bonds, and they are 1, 2, 1, 2, 1, 2. So they are 1 single bond apart from one another. So that will be conjugated. And one more time, the conjugated will be the most stable. Cumulated will be the least stable. And there you go. The next example is just purely looking at levels of conjugation and the next answer. This next question is purely asking about levels of conjugation, because we're talking about order of stability, and we can see that all of these are conjugated. And we're not going to talk about the aromatic effects that are going on in these two, because we actually haven't covered that yet, but that's completely okay. We don't really need that. Again, we're just going to focus on the level of conjugation. With that, I also want to mention that this molecule would not exist exactly the way that it's drawn. I just kind of did that because this handout was Valentine's Day themed. So again, pretend that that's okay. We're just looking at level of conjugation. So now getting into the actual question, all we have to do is count the number of double bonds that are conjugated. So starting from number 1, we have 1, 2, 3, 4. Number 2 has 1, 2. Here we have 1, 2, 3, 4 again. 1, 2, 3, 4, 5. Okay, so number 2 only has 2 double bonds in conjugation. That is clearly less than all of the rest of them. So it is going to be the least stable. After that, we see that 1 and 3 have the same number of double bonds in conjugation. However, we do know that benzene is special. It's aromatic. And even though we haven't learned about aromatic rings yet, we know that benzene is special. And benzene is the only aromatic compound we already know from Orgo 1. And the key here is that if something is aromatic, it has an even higher level of stability. So even though 1 and 3 both have 4 double bonds in conjugation, since 3 is aromatic, it will be more stable. So we would get 1, and then 3. And then the most stable is going to be number 4 because it has 1, 2, 3, 4, 5 double bonds in conjugation, and it does have the added stability of being aromatic, but again, we'll cover that in the next video. So our order of stability would be 4 as the most stable, then 3, then 1, and then 2 as the least stable. That's all I got for you today. Bye!